Hello, my name is Don Dingwell, and I teach at the University of Munich. I am a geoscientist, and my undying fascination is dedicated to how the Earth works. Almost everyone would agree that Earth sciences are somehow a quite important element of our lives. Yet, most do not have a clear grasp of how geoscience functions. I would like to invite you to go deeper in your understanding of the Earth, and the path I would like to take is an unusual one, straight through the heart of one of the most energetic events that our planet produces, volcanic eruptions. Increasingly, people have become aware that the Earth is regularly subject to very violent natural events. Earthquakes, tsunamis, tropical storms, and volcanoes, to mention but a few. In fact, geoscientists define a living planet as one with active volcanism. By this definition, our Earth is very much alive, with many eruptions each year and with a far greater number of active volcanoes that can potentially erupt in any given year. In detail, each eruption is different. Each volcano is its own physical and chemical system. It occurs in its own geological location, and it's subjected to its local stress field. And finally, it is at its own stage in the evolution of geological time. External triggers of volcanic eruptions are also believed to play an important role. Yet, powerful generalizations and models of volcanic eruptions are indeed possible, and in fact, very useful in dealing with the consequences of volcanic eruptions. How are such models constructed? They must rest on the basis of a mechanistic understanding of what volcanoes are and what they are doing, not just during eruptions, but also in the events leading up to eruptions, and not just at the Earth's surface, but also at depth, where the magma is being prepared for the next eruption. And so it is that next to field observations of past eruptions, monitoring of signals from magmatic systems, and computer-based simulation of volcanic eruptions, increasingly high pressure and high temperature experiments are employed in order to answer the question of how volcanic systems work. These controlled laboratory conditions of experimental volcanology are transforming the study of volcanoes from a chiefly observational discipline, where eruptive mechanisms were developed via theoretical analysis of such observations, into a fully modern scientific discipline where such theoretical approaches are either verified or rejected by the experimental picture of what is possible and what is not possible. It's an unconventional subject, an unconventional approach, and some truly unconventional conclusions. Join me as we try to figure out what makes volcanoes work.